Thanks for having me. My name's Erik Bryn. I'm on the Ember.js core team, but I'm not here today to promote Ember. I'm here to just talk generally about web components and share some of my findings. And out of curiosity, how many of you have played around with web components already? All right, so like definitely less than half. All right, cool. So hopefully this won't be too basic. You guys will come out learning some of the basic proposed web component APIs and everything. So cool. So again, yes, I'm Erik. I had a bigger beard in that photo. So what are web components? Web components are basically a group of standards that we'll mention in a second. And I believe, and I think the web components spec authors would also agree, that basically their point is to make building make building web UI, sharing web UI components, and reusing that code on the web much easier than it is today. And so the primary driving force behind web components right now has been the Google Chrome team. And so the Google Chrome team has been working on web components actively for the last 2 to 3 years, I believe. So this is what I'm going to be showing you is a culmination of their efforts over quite a long time. And some of these concepts have been actually in development and been worked on for even longer than that. And so I've been lucky. I've been able to go down to Mountain View and hang out with the godfather of web components, Dmitry Glaskov. So here's our nice selfie. As you can see, the beard's looking a little fuller than it is today. And so the web component specs we're going to talk about, there's basically 4 of them. Those are custom elements, templates, HTML imports, and shadow DOM. And so let's get started by talking about custom elements. So custom elements are probably the easiest and the easiest spec to understand. And it's also, I think, what most people, when we're talking about web components, they are thinking of custom elements. So, you're probably used to today doing something like this, where, you're setting up some markup structure in your document, in your application, setting some kind of ID or unique class name on it, and then in your JavaScript code, you're you're executing some JavaScript, going into the DOM, trying to find those elements that are related to the component that you're trying to instantiate, and then you use something like a jQuery plugin to kick that off. And basically today jQuery plugins are kind of like the lowest common denominator way of sharing UI code across different applications and across frameworks as well. So basically the idea behind custom elements is, what if we just simplified this to a custom tag? And this custom tag can have its own class that defines all of the that has lifecycle hooks and can define basically and instantiate all the JavaScript related behavior for this piece of UI. So how do we create this custom element? Well, today's custom element API looks something like this. Hopefully this is big enough for everyone. Let me see if I can boost it. Yes, I also needed that. Basically today, we don't really have a class system in JavaScript right now. We've got one coming up. But today, basically, you end up writing this lovely set of code. And so just to real quickly talk about each one of these callbacks here, or to walk through the code, what we're doing here is creating a prototype object for the component we're building, and then we're setting a bunch of callback functions on that object. And these are standard hooks defined by the custom element API. And so created callback you can think of as the instantiation hook. This is kind of like your constructor function. And the attached callback, it means the DOM node has been already instantiated and now has been put inside of the document itself. Detached is the opposite. It's been pulled out of the document. And then attribute changed is a callback that'll get fired when any of the attributes of the element change. And we'll see an example of this. We're going to do some live coding and build a little simple component in a minute. So then we call the document.register element here, which does the work of actually assigning the tag name here, which is the first argument, to the prototype object for our custom component. And so it's possible for you to also add any other arbitrary properties or methods onto this prototype object to define the API of your component. But this API is a bit face-palmy. But thankfully, we have ES6 classes coming, and so now there's going to be a nice clean way of defining your custom element classes. You'll actually be able to extend the built-in HTML element class or any of the other subclasses of it, and you'll get a nice, much simpler syntax for defining all these callbacks as well. So this will be great. So without further ado, let's dive right in. I'm being ballsy and trying to do some live coding here, so let's see. Hopefully the resolution will not be god-awful. All right, okay, the left side's all right, cool. All right, so let's go ahead. I will bump the font size for y'all. So we're gonna define a file called customelement.html. And so this will be just a standard boilerplate HTML document. And what we're going to do here is just throw in a script tag. And we're just going to create a component called myComponent. So we'll do myComponent prototype equals object.create HTML element, such boilerplate. And then what we're going to do with that is get our actual constructor function out of document.register. We're going to call this my-component. And we get to pass a lovely looking hash with prototype. All right. So that gets our element registered. Let's go ahead and bring this up in our, oh boy. So we'll do this. All right, so hopefully we're all good, no errors. So let's try actually use it. Well, let's actually implement some callbacks first. So we can go ahead, add the created callback. And so again, this is the callback that's going to get fired when our component, our custom element gets instantiated, right? And so the simplest way to instantiate our element is to obviously just drop it into the body here. And so let's see how this works. All right, that's good. We hit our breakpoint. And so if we look at this here, we're going to see that it's an instance of my component, and two strings to HTML element. So that seems good. And so created callback is the created callback is where you're going to do the kind of work that related to any kind of instantiation or setup of properties or attributes related to your element. You might actually create any subdom that you might have. You would do a created callback. The attached callback is where you're going to actually do things like setting up your event handling. And so things like event handling, maybe calling off to jQuery if you wanted to do some wrapping of jQuery plugins inside of web components. The attached callback is the place to go. And the detached callback, of course, is going to be the place where you're going to want to tear down any of that stuff you did in the attached callback. And let's also real quickly look at the attribute changed callback. So this one actually gets some arguments. All right, and so just for the sake of understanding the life cycle of these callbacks, let's actually manually append the myComponent, our component to the DOM so that we can watch all these callbacks get called in order. So first things first, we'll go ahead and create a new instance. This is just going to use createElement. So we can call document.createElement just like any other element. Pass in myComponent. And I'm just going to throw debuggers in between each step here. Then we're going to call document.body.appendChild to bring it into the DOM. And then we're going to do a set attribute here. And then we'll go ahead and remove it from the DOM as well. All right, so let's see how this lovely set of debuggers fire. So we can go ahead and create our element, and as we would expect, the created callback should get called. And so there it goes. We append the child. We're going to see the attached callback get called. Now, here's one of the more interesting callbacks. Set attribute is going to trigger an attribute changed callback. And inside here, we'll get the name of the attribute, the existing or old value of it, and the new value of it as well. And then, of course, remove child is going to trigger the detached callback. So pretty simple stuff. And hopefully you can see the usefulness in this. I mean, basically the real value here is standardizing around these callbacks and having everybody, no matter what framework you use elements, HTML elements at the core, right? And so when you're talking about distributing UI components, it's very attractive to build at a level that every framework can understand, and that's obviously the DOM element level. So from here, let's jump forward. Hopefully I can, oh, come on. Of course it doesn't just work. Boom, great. All right, so let's just quickly recap. How are we kind of doing this stuff today? Again, like I mentioned at the beginning, where if you're using something like a jQuery plugin, you tend to do something like this, and configuration is going to get passed in to that jQuery plugin call. If you're using something like Ember, then Ember provides something similar to custom elements today, which is basically we create you handlebars helpers automatically when you register a component class in your Ember application. And so inside of your markup, you can just drop in curly's my component, and then you can pass in key value pairs, and those can be primitive values, or they could actually be data bound as well. And so in an upcoming version of Ember, we're going to actually enable you to just write this custom element syntax, and that will actually delegate over to the handlebars helpers that live underneath, that actually do the work. And so this enables us to have something like custom elements in browsers that aren't going, in older browsers that aren't going to support the custom elements API or aren't polyfillable as well. So that's kind of cool. In Angular today, you've got several different ways of kind of doing something similar to custom elements. They're called directives, and you can definitely do the straight up custom element approach, which is which is called an element restricted directive. And so this first example here shows, did it lose its zoom? No. This first approach shows you can just use it like we would expect, but they also have they have several different forms, but I think the most popular ones are the element and attribute restricted. So here you can actually just drop in an attribute saying my component, and that'll automatically trigger Angular upgrading that element to something web custom element-esque. And so the cool and exciting thing is that Angular 2.0 has actually said that they're going to be adding web component support as a first-class citizen. That's nice, because that means potentially these things can be used across Ember and Angular applications. And again, and also Polymer, which is a cool library that's basically built on top of all of these new web component primitives. It has you can use, obviously, the component in a similar way as you would expect, but they have a really neat little declarative form, which is actually a custom element itself. So if you use Polymer element and pass a name, that'll actually do the work of setting you up a custom element named my component, and you can put some markup in there, and you can immediately start using that. And if you need to, that's mostly for simple use cases, but you can do that, and also then go into the JavaScript side and actually define your custom element using their sugary APIs for doing so. So I think personally, as a framework author and an enthusiast for web technology, I think the really exciting thing about custom elements and web components in general is the potential interop story that can be unleashed. And so this is still somewhat uncharted territory, but we're working together both from the standard side and on the framework side to try to find a way that Ember, Angular, Polymer, et cetera, can all build. You'll be able to use these components in any framework, potentially build them inside of your application, extract them, use them in another app, and that's, to me, one of the big promises of custom elements is, since it is kind of this lowest common denominator mechanism for defining and sharing these elements, you can actually envision an interop story being possible. And so the current proposal, if you're interested in looking into it, is called node.bind. And so this is basically a mechanism for how, really the unsolved problem here is how do different frameworks, data binding solutions work across these elements that can be shared. And so that's what node.bind is trying to address. So this is cool. Obviously, I'm developing Chrome, and custom elements have shipped in Chrome, so you're able to use them without a flag today. The Firefox team has begun implementation. I've heard that they have it implemented and it's working. I was unable to find any documentation about where it was flagged or what the render prefixes were or anything. So otherwise, I would have showed you it working in Firefox. But this stuff is actually usable in browsers without native support. Google, the Google Polymer team actually, as part of the work of building Polymer, and created a polyfill library called Platform.js. And so Platform.js is usable. They say they target all modern evergreen browsers. And so the idea is you can drop in this JavaScript dependency and get support on browsers like Safari and IE. Opera, so Opera is based on the Blink engine now. So if Chrome typically has a feature, Opera has one too. So, so yeah, it's pretty exciting. So the next topic, the next spec that I want to talk about are templates. And templates are actually probably the template spec is actually a lot simpler than probably you think of when you think of the idea of a template in JavaScript. So templates are actually just a mechanism for declaring fragments of markup, and it enables us to easily clone and insert them around. So here's a simple example. Basically, there's now a template tag, and this is around in Chrome. We'll see in just a second. We can use this today. And so the idea is you can define one of these template tags. You can put any arbitrary markup inside of it, and then you can very easily fetch it out of the DOM, call template.content.clone node, and this will actually create a clone of all the content inside of that template tag, and then you can append it somewhere. And so today, if you want to do something like this, you're probably thinking, well, wait, hey, what's so fancy about this? This isn't that big of a deal. So today, if you're doing this kind of thing, you're probably using something like a div, and you're doing display none. And so template tags, by default, do not have any rendered output. So this is just you can kind of think of it as a declarative way of doing a document fragment. Right? You can just you can basically create a document fragment inside of the DOM. And so, if this markup is getting generated by your server, you're able to actually have your server emit markup that isn't going to have any rendered effect on the client's machine. And so, again, another strategy, and this is a strategy we utilize in Emberland when we're trying to, in our starter kit in non-build tools, style environments, is you use a script tag with a custom type. And so basically anything inside of that script tag just becomes text, and then you can suck the text out of that element with inner text, and then you can go and inject that into the DOM, and then clone it from there if you need to. So the big important and the big important feature about templates are that they are inert. And so what this means is that you know, I'm sure if you've tried any of these other approaches, one of the big, even though something's displaying none, doesn't mean that that interpretation and rendering of something that isn't visible doesn't still have an effect on the user's environment. And so a common example of this are image tags. So if you wanted to have a piece of you know, template code on your machine, on your client's machine, and that hasn't been displayed yet, and you put an image tag in it, it's going to download that image immediately. And so you're potentially bottlenecking your application's boot time by loading a bunch of unnecessary assets that, you know, aren't going to be displayed right away. The other big one is script tags. So if you have a script tag inside of that template, that script tag will not actually execute until it is appended to the DOM. So let's take a quick look at templates. So we'll drop in a template tag with an ID. Oh, thank you. Thank you. All right, there we go. We'll drop in a template tag with an ID. Call it my template. And so let's just start off with a super simple example. We'll do the good old hello world. And so we'll write some code to grab this template out of the DOM. And so if we look at template content here, this is going to be a, the nice thing again about templates are this DOM is actually parsed as well. So you get through the parsing phase and this DOM is extremely quick to then clone and append versus an approach like the script tag approach. You offload the parsing until you actually suck the text out and jam it into the DOM. And so you end up paying a little bit of a performance cost there. So we can go clone the content. We'll get a clone, and then we can just drop that into the body. All right, so easy, right? Not so bad. So let's actually prove that these templates are inert. So if we go ahead and drop in an image tag here, I'm not appending it, and if we go to the network tab, we are not seeing that image appended, right? Whereas if we were to do some existing solution, right? If this was just some div here, hopefully this is obvious, but I'm just proving it to you that it's true. Hopefully I'm not wrong. That would be embarrassing as hell. Chrome has some new optimization where they don't load images all of a sudden. Oh, I have double the ID. Whatever. So yeah, as you can see, even though it's hidden, right, that image got loaded. And then of course, hopefully, if that's true as well, it's obvious that putting a script tag in here is also going to get executed, right? Even though it's off screen, right? So this inert property of the template tag is quite handy. Yep.
What's the difference between the template and just a regular script tag with a type of tag?
So as I mentioned briefly, the idea is that the contents of the template tag actually get parsed by the browser, and the DOM nodes, you know, the initial DOM nodes get created, and you know, those nodes have some special properties like this inertness in the cases of images and scripts. And the advantage here is that it's actually clone node is the fastest way to generate DOM in the browser. And so it's actually extremely fast to take that already parsed and, you know, generated template DOM clone it, and then jam it in somewhere in the application. Whereas if you're doing the script tag approach, you're going to be paying that like inner HTML cost as that user interaction might be occurring that is going to be parsing and then appending it. So depending on the amount of DOM that you're creating, that might actually be cost prohibitive in a certain circumstance. Yeah?
Alert will come up every time you append the child?
So yes, every time you clone and append, right? Because if you append, if you're taking a node and appending it multiple times, you're just moving it, I think, right? So.
Will kind of cache it. The clone will be like.
Well, so it's not so the idea is that I don't actually think the template tag does anything to specifically cache it. I think if you do not clone, you can actually steal DOM out of the template tag, and then the next time you try cloning it, it won't be there anymore. So you need to be careful to actually clone the contents of the template tag here, which is what we're doing on line 15. And so now, just to show you again, we refresh now. That alert doesn't get fired. When we append it, it's going to get fired, right? And then there's our success message. And then, of course, if we were to continue to clone and append, then we would see that same, we would see the same thing happen again, right? Make sense?
What is this Boolean flag?
Boolean, oh, recursively. Yeah, so clone node by default is non-recursive, not deep, and true means do it deeply. So, any other questions before I move on? All right, cool. That's the template tag pretty much. So let's move on. Come on. I don't know why I can't get over there easily. All right, so templates you should really think of as they're a very low-level primitive, right? They're basically a nice new way of having markup, of generating document fragments via markup rather than via procedural JavaScript code. And so, my hope is that, and I think, the hope of the spec authors is that the template tag is basically, our foot, dipping our toes in the pool here around this whole templating problem, and is going to be a primitive that enables something higher level to be actually implemented in the browser. And so, it would be cool to see some simple data binding systems potentially be standardized in the future as well. And so what I mean by that is something like this, right? Like this is the kind of thing you're used to already with your existing libraries and tools, libraries and frameworks today. So it would be nice if we could, in theory, create a template tag, put some special markup in it, and then, this magical render. I just realized my cursor does not actually show. I'm looking at my notes. So this render method here could perhaps take a JavaScript object, and that would automatically populate, any of the data bindings inside of the DOM. So it would be cool if something like this existed, right? But not yet. Sorry. So it's an important point to note. It's an important point here that while there's a lot of hype and craze around web components, there's actually still a void for frameworks and libraries to fill, and so we will do that. So the next spec that I want to talk about is HTML imports. HTML imports enable you to include and reuse HTML documents in other HTML documents. So this is kind of a little bit of a mind bender. You can kind of think of it as, just like you can link a style sheet into a document, you can also link another HTML page into a document. And so really what this is all about is, as you've seen with the, with our as you might imagine, with templates and with custom elements, we've got both HTML markup and JavaScript code now. And the idea behind HTML imports is like, wouldn't it be awesome if there was an easy way, a one-liner way of bringing all of those assets, the markup, the JavaScript, and the CSS into a page, without any build tools, without any real conceptual overhead. And so here's an example. We're just dropping in an import, and then now magically we have an element that we can use, right? And so, like I said, this is a really dead simple way. It's meant to, I think, be as simple as possible, and it is designed for that in mind. But the really cool thing about this, but it has, you know, some exceptions and some complications behind it, is that the cool thing is that if the imports you are using happen to share common dependencies, those will only get loaded once. So imagine you're using, you know, jQuery in several different components, or in several different, you know, HTML imports, and you know, those, as long as those jQueries are coming from the exact same URL, they will only get loaded once. And so that's kind of the gotcha. So, you know, it's I think a really good, the way I view HTML imports are, you know, there's several open questions in my mind about their production capability, their production use, but I have not seen anything simpler for somebody who's perhaps new to web programming, for them to be able to, you know, go grab a URL for a component, or have downloaded something to their local machine, you know, and put it in their local directory, for them to be able to bring in something that they can just then use as a tag in their existing markup. This is a really great solution to that problem. You know, but again, for production use, I think, you know, there's actually some tools that have been developed to actually do proper packaging and concatenation, like you would expect, like you probably are doing today in your production applications around HTML imports. But again, these things are very new. So let's take a look at HTML imports. So yes, thank you. I'm sorry? Can you use a link inside of? Yeah, I don't see why not. Yeah.
Do you know if CSS gets?
So CSS is also included in this, right?
It doesn't get sandboxed on it or something? Or?
No, it doesn't get sandboxed, but we're going to talk about Shadow DOM in a second, and that's what will take care of that for us. So here we are, very simple document. In our head, we're going to do a link rel import. href equals some, you know, import. I'm just going to say imported element, something. And so now, ideally, we want to be able to use that imported element inside of our page. I can type. All right, so now we're going to go create an imported element.html file to import. And so we're running a little short on time, so I'm just going to copy and paste this over. So there's a little funkiness going on here and around the document object. And basically, the idea is, I don't know if this is going to end up being the way that it is in the final spec or anything, or the final implementation. But basically, the idea is here, technically, the document of this other HTML file is different than the document of the originating file. And so I'm doing some trickery here to basically grab the document from our HTML import.html file. And so therefore, we're registering the element on the person importing us, not ourselves. What's that?
What about global scope? What if you create variables here?
Mm-hmm. I believe window is the same, but I don't know. I haven't actually tried. Let's find out. So let me real quickly, this is fine, except I called it imported element. So we'll throw debugger in there. And why don't we do something silly like window.itsme. All right. Let's do HTML imports. Where's import? Import. All right. So window. So we hit our breakpoint. Window dot its. No, it does not look like window is the same.
Before your script?
I'm sorry?
Wouldn't that execute before the script tag?
Oh, maybe. Good point. Let's find out. We can actually maybe use the attached callback. But yeah, you might be right. So let's do this a different way. Let's actually check inside of here, maybe. And try doing it the other way around. All right. Did I not set a breakpoint? Oh, I didn't save. All right. So that's interesting. Okay. Yeah. So it looks like the window is the same. We just had an ordering issue with my initial check. So yeah, basically all I'm showing here, just focus on the original intent of the demo, is that we've got our custom element defined inside of this other HTML file, right, which we are importing via the link rel import tag. And then here in the attached callback, all I'm doing is just inner HTMLing a string so that this element actually has some content. So it's working. Great. That's all there is really to it about HTML imports. Come on. All right. So here's the complicated and oh wow, I'm already out of time. Here's the complicated part of the talk, which is Shadow DOM. And so I'm not going to dive too much into Shadow DOM because it is complex. But the important thing that I want you to get out of and associate with the concept of Shadow DOM is that Shadow DOM enables encapsulation of the DOM. And so what I mean by that is a couple things. The most important bit, which is, as the gentleman up front here asked about earlier, is does it isolate the styles? You know, does HTML imports isolate styles? No, but Shadow DOM does. And so let's try to whip together an example of this. And not only does it isolate styles, it also helps you kind of reason about these it enables us to think in DOM APIs as well, and I'll try to point out what I mean by that exactly before I completely run out of time here. So here's an example, a code example. So this is how you use Shadow DOM. There is no declarative API to use Shadow DOM by default. Polymer exposes one, but basically the idea here is that you can create a template. And you can define a style tag. You can put a link tag in here, import some CSS, and then put some markup here that is being styled, obviously. And what happens here is if you check it out, we grab a reference to our template, we clone it, then we create a div, and then we call a method on this div's element called create shadow root. And so what this does is it creates another. You can kind of think of it almost as like another complete document in a way, so almost like an iframey type thing, right? Where basically you've got a separate DOM hierarchy now, and you can put things inside of this, and so we go ahead and it looks like it operates like a node, so you can just call shadow.append child, drop the clone in here, and then you can append that element, the original div element to the body. And so now what's going to happen is that this p style, which is extremely generic, right, and which you would normally avoid using in your application, actually is not going to leak outside of the shadow root of this div. So let's try to get a simple example of this working. Another thing to think about, or another way to think about Shadow DOM is the way that I like to describe it is that the Shadow DOM is kind of like the layout of your component, and so you get to separate the layout and its styling from the contents of the component that the user is providing, right? So the contents the user provides is actually styled based off of their application's style sheets, not the components. So. All right, we are really short on time. So let's see here. Maybe I can reuse one of these examples. It's probably easier to just. All right, so we're going to basically just. Thank you. I'm epic fail at this. Let me actually grab this stuff. All right, so we're going to grab a template here. And so what we'll do is, thank you. You guys are so helpful.
Can you add a key outside the template so we can see that it's not blue?
Yep, we're gonna do that. Just 1 second. So, so let's go ahead. Hopefully this will just run. All right, cool. All right. So again, this is really kind of like, for me, this has been one of the biggest missing primitives on the web that really gets in the way of code sharing because all it takes is like one library to have a colliding style or class name or ID or whatever, right? And it blows up, and there's not really much you can do. So Shadow DOM's, kind of the solution to this. And before Shadow DOM, there was the concept of style scoped, but it looks like for all intents and purposes, style scope is dead, and Shadow DOM will be the solution. So real quick, let's finish up the deck, I guess. Oh, yes, mirror. All right, so we did the demo. All right, so to wrap up, Web Components are bringing new features to the platform that hopefully you can see are going to really help to enhance developer productivity. We've had a lot of work done to like add features to the web, like APIs that allow us to get access to device capabilities and do video conferencing and stuff, but we really haven't focused on features that help make us more productive doing our jobs, and I think Web Components is kind of the first big step in the right directions with regards to that. Unfortunately, as the way of the web, we're a year or two away from this stuff actually landing natively in all of the browsers that we probably need to support. But as you know, browser development is happening at a much faster pace than it was just a few years ago. So. And it's important to realize while these features are coming, the library and framework folks are going to still play a big important role to help all of you start using some of these features today, even though they might not be natively implemented. And that's awesome. So it's a really exciting time to be a web developer with all this new stuff. So thanks so much.